Hey, welcome. Here we go. We're on to section 1.4, and this is the video for our notes with definitions and questions. 1.4 is now talking, we're continuing with angles and just certain pairs of angles, different terms for how pairs of angles can interact. So let's take a look at the definitions in our notes, 1.4. The first definition is adjacent angles. What are adjacent angles? They are two angles with a common vertex or a common side. And again, because sometimes I think a picture is worth 1,000 words, here we go. And that's why with every definition, just a reminder, you need to have an illustration or an example. If I have an angle here, and then I draw an angle there, these two angles are adjacent because you have an angle, you've got this angle right here, and the second one is next to it, and you can see they have a common side. This is the common side, and they have a common vertex. The common vertex is right here. Okay, so adjacent angles just means basically two angles that are right next to each other. And they need to be able to share a side and share the vertex. An example of non-adjacent angles would be something maybe like this. Where again, they have a common vertex, but if I'm talking about this angle and this angle, they're not sharing a common side. So this right here sometimes would be a good non-example. That is not adjacent because they need to have a common vertex and a common side. Okay, so just our term for two angles that are next to each other, like sharing a wall in an apartment building or something. They share the same, they share one side with each other. Okay, a linear pair. So this is a type of, as you can see, adjacent angle. A linear pair are adjacent angles that form a line or a straight angle. So we've talked about a straight angle. A straight angle is a line that is 180 degrees because that's how many degrees that would be. Deep stuff, I know. So if you have a straight angle and then you form adjacent angles from that. So here we have an angle here, and we have an angle here. Those would not only be adjacent angles, they share a common vertex and they share a common side here and here. But they're a special type of adjacent angles. They're a linear pair because they come together to form this straight 180 degree line. So a linear pair is just a special type of adjacent angles. Anytime they form, again, that straight line together. Another thing to note that you would maybe add to your definition is they always, I'm going to change colors, they always add to 180 degrees. So by definition, if they're forming that straight angle or line, you know that those two angles together will always add up to 180 degrees, which when solving for different values, that's useful to know. Okay, then we have these two, complementary, supplementary. I can't exhort you enough that as we define these, you've come up with a trick to tell them apart because you can see they're two very similar words that mean different things. And when it comes to then solving a problem on the fly, if you don't know which is which, trouble ensues. So complementary are two angles that come together and form a 90-degree angle or a right angle. I'm going to add that to my definition there. So in other words, we have our right angle, 90 degrees, and then if we divide that into two different angles, these two here and here would be considered complementary because I know that if I added, let's just call them angle 1 and angle 2, if I added those two angles together, I know their total would be 90 degrees, or together they would form a right angle. So complementary means they add up to 90. Just so you know, it doesn't necessarily mean that they have to be adjacent. You could have an angle here and then maybe an angle over here. And if you were to be told that, say, angle 1 and angle 2 are complementary, even though they're not adjacent to each other, you could know, well, that just means that if I add those two angles up, they're going to add up to 90 degrees. So they don't have to be adjacent. Any two angles that add up to 90 degrees are complementary. Now, to complicate that, we have what is known as supplementary. Supplementary, it's the same idea, but it's like, okay, what do they add up to? Supplementary angles are linear pair angles in that they add up to 180. So when you have a flat line or opposite rays or a linear straight angle, angles, in this case, angles 1 and 2 would be supplementary, because if I add this angle 1 plus the degrees of angle 2, now I'm going to get 180 degrees. So same idea, but again, you want to know the difference. When you see supplementary, you want to think 180. You want to think 180. When you hear complementary, you want to think 90. Okay, we could also note here, as I just said, that these are also what we'd known as a linear pair, because they form that straight angle. Or we could go ahead and amend our notes up here that a linear pair is supplementary. The way that my little just simple trick just to differentiate them is alphabetically. C comes before S, complementary, supplementary, and 90 degrees comes before 180 degrees. In other words, it's smaller. You get to 90 degrees first before you get to the 180. So I just remember the C is the smaller, the S is the bigger. But come up with some trick, because I've seen it time and again people mistaking whether they're adding up to 90 or 180. And then we get to vertical angles. Two non-adjacent angles formed by intersecting lines. Might not mean much to you, so let's just go to the picture. It's much simpler to explain that way, is just draw any two lines that intersect. So something like this. And it's the two angles that are not adjacent. So if I'm talking about, say, this angle here, the vertical angle to that angle is this one, not next to it, not here or here, because those are both adjacent. So not those, but this angle here. So I think of it as the angles, it's not very precise, but the angles opposite of one another. Sometimes an imprecise definition can still be helpful to remember it, of one another. So in other words, these two angles here are vertical angles, and this angle here has an opposite angle to the right of it right here. So the relationship is those that are across from each other, or again, the non-adjacent angles. And notice that the bonus fact here that's very important is that vertical angles are congruent. Okay, so in other words, if this is, say, 130 degrees, oh, sorry, that looks terrible. If this one here is 130 degrees, then I know this one must also be 130 degrees. And that if this one over here is, that would be 50 degrees, then this one over here would have to be 50 degrees. Okay. Notice also how I pick those numbers. If I say this one is 130 on top, I know that the ones next to it have to be 50. Why? Well, because look here. These two right here are supplementary, or they form a linear pair. And that has to add up to 180. So I know that 130 and 50, that's the only possible value for that. Once I know the 130, I know what the other one has to be. And that extends all the way around. These right here are also form a linear pair. So they must add up to 180, and that applies all the way around. So that's the idea about once you know these concepts, you can start to find values within angles and intersecting lines very quickly. But all that to go back to vertical angles. Wherever you see lines crossing, it's the opposite angles across from each other that are vertical and congruent to each other. So let's take a look at some of the questions for this lesson. And again, this is might be a little confusing in the wordage, so hopefully this video is helpful in what we're trying to get at. Number one says, if angle M is a complement of N, how could you express its measurement without knowing either value? So what are we getting at there? It's an algebraic concept or method. So here we have angle M and N that I've drawn, and they're complementary. So that means they very good. They add up to 90 degrees. So I know this is a 90-degree angle. So say I don't know any of the values. I don't know what M or N is. How could I express, say, the value of M? Well, what I know is that M, this angle here, is the entire 90 degrees minus how much? Well, minus N right here. So, in other words, M is equal to the total of the both angles together minus the complement. So I know that angle M would be the same as 90 minus N. Or, if I was going to express angle N, I would know that angle N is 90 minus M. And so that you're going to find that's a way of expressing it, even though you don't necessarily know what the what you don't have a specific value or number of degrees to work with. So just remember, you can always express a complement with the sum total minus the other side. The second question says, what if angle N is 2y minus 20? So if we now say that angle, I'm going to switch colors here, second question. If this is 2y minus 20, how could I express angle M? Well, I could simply say, well, angle M must be 90 degrees minus 2y minus 20. Okay, because that's basically what N is. And now, because I now have numbers here, I can simplify this. Notice I put the parentheses. Whenever you subtract in algebra, one of the big tips that hopefully your algebra teacher emphasized is you want to put it in parentheses, because what happens here is when I subtract this, I'm subtracting 2y. We're actually subtracting 2y, but we're then subtracting a negative 20. So this actually becomes a positive 20 over here. Because we're subtract. So if I rewrote this, it would actually look like 90 minus 2y plus 20. Because I'm subtracting the 2y, but then subtracting the 20 that's already negative, so it becomes positive. We call that distributing the negative. So whenever you're subtracting an expression, you want to put in parentheses and make sure you apply that negative to everything inside that expression. So now we could simplify this. 90 plus 20 is actually 110. Minus 2y. So if, going back to the question, if N is 2y minus 20, then M is equal to 110 minus 2y. And again, how did we get that? We got that by taking the total of the two angles, subtracting the other angle, and in this case, if we know it's 2y minus 20, we can simplify it a little bit, and we can get this expression. If I didn't have that much information, well, that's what the first question was. M was just equal to 90 minus N. And then the third part of this question simplifies it even further, is what if I just knew that N was plain old 33? What if I knew that this was 33 degrees? Well, remember what we just learned, that M is equal to the total minus whatever N happens to be. So I could just, I'm running out of room here, but we can go, I would just say, okay, so in that case, M is equal to 90 minus 33. Oh, you mean so angle M is equal to 57 degrees. Yes. All right, so knowing that they're complements allows you to find, if you know one of the angles, and if you know they add up to 90, you can find the other angle pretty easily. In the case of the orange example, if you know the exact measurement, you just subtract and you go, oh, so if one's 33, the other one has to be 90 minus 33, 57. If you don't know a specific number, but you have an expression like the 2y minus 20, well, just write that. You're not going to be able to solve it, but you can write 90 minus the 2y minus 20, and you can at least get an expression. And you'll see there's some exercises in the homework today that are like that in the next video. Okay, a little confusing. Maybe rewatch that segment or talk about it when we go live, because I know that I've seen students struggle with that before. Number 2 says, similar, but I think a little simpler. It says angle J is 105 degrees. What is the measurement of the angle with which it forms a linear pair? So I've drawn, again, a linear pair. Remember, it's a line divided into two adjacent angles, and we know that it has to add up to 180 degrees. This whole straight line has to be 180 degrees. So to find the missing side here, with which the one that it's forming the linear pair with, again, it's very simple. 180 minus 105. Okay, which leaves you with, what is that, 75? 75 degrees. That's like what we did there in the orange. If there's supplementary, you know the two angles have to add up to 180. If they're complementary, they add up to 90. Then it asks the question, well, what about if the two angles were not linear pairs, but they were vertical? So I didn't draw this, so let's just draw that real quick. What if instead I had vertical angles like this, and I knew that the one up top was 105? What would be this angle down here vertically from it? What would that be? Okay, well, if we go back to vertical angles, we can see that vertical angles are congruent. So this is the even easiest one. So if I know that one angle is 105 and I'm trying to find its vertical angle, I know that that also must be 105 degrees. So vertical angles are always congruent. Supplementary angles, we find them by subtracting one of the angles from 180. Complementary angles you find by subtracting one of the angles from 90. So it all depends on what they're adding up to, or what their angle pair relationship is. And last one, number 3. If two angles are complementary and congruent, what must their degree be? This is just a special case that I wanted to point out to everybody so that when you see it, you're familiar with what they're getting at. Again, it's saying that two angles are complementary. So that means, say, here we have angle 1 and angle 2. They add up to 90 degrees, right? So it's saying they add up to 90 degrees, but it's also saying that they are congruent. And so that means that angle 1 is the same as angle 2. Well, let's think about that. If they have to add up to 90 and they have to be the same value, what number, what would be the evenly split number of degrees in 90 degrees? Basically 90 divided by 2. And so that means they both have to be 45 degrees, because no other angle would allow them to both add up to 90 and also be equal to one another or congruent to one another. So they would have to be 90 degrees. I'm sorry, 45 degrees. And then you have the same situation you could be asked with supplementary. If the two angles here are adding up to 180 degrees, because they're supplementary, and you're saying that they are congruent to each other, so they're the same, it's the same idea. The split of 180 would be that both, and you can see it from the drawing, both of these angles would have to be 90-degree angles. And so whenever you see that thrown at you, complementary angles that are congruent, they both have to be 45. Supplementary angles that are congruent, they both have to be 90 degrees. So just a special case that I wanted to get you thinking about. Alrighty, so that takes you to your exercises where you can try some of this out. Page 31, 1 through 13, 23, 27, 29, 35 through 41 odd. And there'll be another video where I'll be doing quite a few of those problems actually, because some of them don't take very long and I want to walk you through them. So if you need that help, I will see you on that video next.